Dr. David Nahamu, he was the manager of IBM Speech. He and Michael Picheni, another speech researcher, and they gave a talk at 2012, and the performance then was around 20% error. So he gave a speech and said, okay, in 10 years from now, we will have a superhuman performance. And I said, no way.
Welcome to The Future Of, a podcast by Fresh Consulting, where we discuss and learn about the future of different industries, markets, and technology verticals. Together, we'll chat with leaders and experts in the field and discuss how we can shape the future human experience. I'm your host, Jeff Dance. In this episode of The Future Of, we're joined by Dr. Yossi Kishet, Chief Scientist at aiOla, a leader in capturing spoken data to create workflows for blue-collar industries. Yossi is also an award-winning scholar with over 100 research papers about automatic speech recognition and speech synthesis. He also has a background as an electrical and computer engineering associate professor and a director of the Speech, Language, and Deep Learning Lab at the Technion, and the Israel Institute of Technology. We're here today to explore the future of AI speech with Dr. Yossi. Yossi, you said that your research interests are driven by a passion for understanding and quantifying speech. Can you share us more about your journey, kind of how you landed in the profession that you have?
So it happened, like many others in my field, it happened when my first job was processing speech. So I work at a company called Variant Converse. It was two companies. This company was creating digital voicemails, and like the one we used to have on the phones. I don't think we use them anymore, but that was a great technology in the 90s. And I wrote for them the speech compression, and I really liked that. It was the first time that the computer program touches the real life, the audio, and that was fascinating. And I want to learn more about that. And I'm still learning. It's fascinating to what you can do with speech. You can understand human condition. You can understand if you're happy or not, your medical condition. It's unbelievable.
Fascinating. We're excited to go deeper. Tell us a little bit more about what you do for fun.
For fun?
Yeah.
For fun, I'm reading books. I'm with my kids. They do a lot of sport. So we do a lot of sport here. We travel a lot in different countries. I like music. I used to listen to classical and opera, and now I listen to hip hop, which is amazing. It's unbelievable. It's really that thing.
That's fun. That's fun to hear. I've had a similar journey myself. Oh, well, good stuff. In the past, we have talked about the future of conversational AI, kind of voice AI. Our topic today is a little different. What do you mean by when we say AI speech, and we're going to be talking about the future of AI speech? Tell us more about what that means.
So we're focusing on mainly two applications. One of them is text to speech, and the other is speech to text. Speech to text is also called automatic speech recognition or just speech recognition. And just to be sure, nowadays, like a year ago, we are standing at a human level performance, even superhuman level performance, better than ChatGPT, superhuman performance on read speech and very good performance on meeting speech or just transcribing, the speech to text. The other application is text to speech, so speech synthesis, and this is also great. I don't think this is what we hear over the iPhone or the Google phones now, but the performance are really amazing. It's also unbelievable. It was a huge step over, and I think it's not as known as images that you see all around, but the performance are unbelievable. It sounds very natural. It can mimic voices.
Thank you. And why is that? You said achieving human level performance, superhuman level performance, better than OpenAI. What are some of the kind of most recent developments in AI speech that have led to this performance today?
Let me correct. I mean, ChatGPT of OpenAI is unbelievable for us as a textual processing. What I'm claiming is another model of OpenAI called Whisper. This is also unbelievable, but it's not that OpenAI did anything except trained that on huge amount of data. It's a known model, not developed by OpenAI, called Transformer. It's the same model of, at least partially, the same model that used for ChatGPT. But it has two parts, this model. Another part that processing the input, which is speech and not only text. And this was trained on 600,000 hours of speech, transcribed speech, so speech that has the transcription. Mm-hmm. And this was never done before. We used to train on thousands of hours, that's it. And this brings us suddenly to performance which are unbelievable, just the data. It's remarkable. The performance are remarkable. We compare that. Actually, we had a paper that we compare American speakers, mm-hmm. Which we call L1, first language, but also we have a speech of L2. So it's Korean people speaking American English, Japanese people speaking American English, various people, what we call L2. So the first language is something else and they speak American English. And under various conditions of noise, we check what is the performance of human listeners and what is the performance of whisper. And whisper outperform a little bit the performance of human listeners. And that is remarkable. This is read speech. It's not spontaneous speech like the speech I'm speaking now. It's not conversational speech or meeting speech, but it's almost there.
That's amazing. So basically, our conference call notes that are automatically transcribed are going to get better and better. And as we're communicating to people throughout the world, when we're maybe we're speaking English, but we're missing some words because of some accents or something like that, these sort of models can help us, can aid us, and also give us accurate meeting notes.
I have to tell you something that it's remind me. So there was a guy, Dr. David Nahamu. He was the manager of IBM Speech, and in 2012, he gave a talk at a conference. He and Michael Piccini, another speech researcher, and they gave a talk at 2012, and the performance then was around 20% error. So every two words are incorrect in a 10-word sentence. So 20% error. So he gave a speech and said, okay, in 10 years from now, we will have a superhuman performance. And I said, no way. How can we are not even close. And that was, I still have the presentation notes. That is really a great step forward.
That's amazing. If we look at AI and human level performance, for the most part, if we go back to 2017, before the transformer was introduced, we were expecting into the 2040s, 2050s, 2060s for a lot of human level performance. It was going to take, 10, 20, 30, 40 years to kind of get human level performance across like 15 different criteria. In the last few years, all those projections have been moved forward, not just across speech, but across like 15 different criteria of getting to human level performance. And obviously we're measuring against human level performance, which is, we are the benchmark, right? And I'm sure for you, it's been kind of a culmination of your career to see things, really, really accelerate.
Amazing times. Yeah. Amazing time to do research.
Right.
We wait so much time from 2017 until now to get that. But now we are really expecting that OpenAI will come up with the next month with a even better ChatGPT that will outperform the previous one.
Right.
We cannot help waiting, but we are still having some gaps. For example, I'm working at aiOla. aiOla, we're targeting to transcribe speech for special domains. So for example, if you're a medical doctor, you have those special words during a surgery, and you want any surgery, you need a transcription. And during surgery, you have those words, and those are not going to be transcribed with Whisper or any other model. You need somehow to tune the model. You need to do something. Or if you are checking an airplane or any industry facility has its own jargon.
Right.
And this is still a challenging task.
Right. Because every country, every industry, every profession sort of has its own jargon, and just training general models probably won't pick up on that unique jargon.
Right. And by the way, those places somehow So if you check an airplane, when they check an airplane before and after the landing, so they cannot bring pen or anything, because if it's left in the airplane is grounded. So what they do is sometimes they just remember things and go to the pilot and they tell him that, and then they write it down. And also in some other, like when you manufacturing nanotechnology, you're all covered with a mask, with gloves. You cannot touch anything.
Right.
You're very limited. Again, the reporting is also with a lot of jargon words, and it's very challenging areas and environments.
So basically, there's a lot of opportunity to create these, to specialize, essentially. Like we have some great superhuman models now, but as we think about all these different use cases and trying to bring great, text to speech, speech to text, there's a lot more opportunity to go further.
Right. There's still gap in heavy noises, reverberant noises, echo cancellation, and speech recognition. When I say speech recognition, I mean automatic speech recognition. I mean transcribed by machine. We would like to recover voices of people who cannot speak or have difficulties to speak. We would like to help them analyze their speech. I'll give you another example, which I did in my research. So, there are kids at the age of 4, 5, 6 that have pronunciation problems. So they don't say R correctly. They say L or Y instead of R. And the goal is, and when they have that, usually they go to a speech therapist. She will tell them, you're pronouncing, lay, and you should say Ray. And he say, no, I'm pronouncing correctly. And when he or she understand that, because there is no problem with the kid, it's just mapped the same phoneme to the same virtual space in the brain. And we understand when the kid understand that, immediately something happens, and then the speech therapy is successful, and then he tries to pronounce his own speech. So what we do, for example, in this research, is that we take the speech of the kid and generate his own voice, generated with the pathology and without it. So he can hear his own voice saying correct and incorrect R, and he can play with that, and he can immediately get the perfect feedback with his own voice. And we also create some avatars, so he can see that maybe his mouth or teeth are not in the correct place and should be in or out, and it's all by the voice. And that can bring speech therapies to location when we don't have them, like Africa, India.
Right, where they don't have the funds or the resources to have, special. I mean, how many kids go to speech therapy? Do you know what the statistic is in the U.S. or in first
in
world
the U.S.
countries?
I don't know. It's something between 10 and 30% in the U.S.
10 and 30% of kids are going to speech therapy.
Something between 10 and 30. It's huge. And there is another thing. I think the mean time for waiting for speech therapies in the US is, I think, 7 weeks. 7 weeks
because there's
of waiting.
Such a huge demand, So having these tools help kids hear their own language, solve their own problems with technology. That sounds really transformational in that particular industry. That's pretty exciting. Who are kind of the biggest players as we think about speech, speech AI and speech recognition and synthesis? And why do you think the big companies are in this space? Is it sort of a fundamental component of technology?
Either they are fascinated by this type of modality, the speech, like me, or they find it really important. So for Amazon, for example, they drive the device, the Echo device and the Alexa device. They drive it by speech, and they have a great team. Meta is part of their FAIR, Facebook AI research. FAIR has a great team of speech recognition, speech synthesis, music synthesis. There is a great team in Google. They have the phone. They have also devices and they need to drive them with voice.
Mm-hmm.
And OpenAI just built the best model ever.
It's crazy. It seems like everything's becoming a vector database these days. It's like what was so novel, so just so recently, is now almost ubiquitous for software developers. We're working on building, working with neural networks over these vector databases, and even our CTO helped write a paper that's been cited like 40 times, and it's about how to vectorize information, which is now fundamental to these advancements. But it's just so crazy how quickly this technology has been unleashed on almost everything, and we have entire conferences on just generative AI for robotics as an example, right? But here we are talking about how this has changed the game in your industry, but it's changing the game in almost every industry.
I have to say something about that, because it's amazing that this happens in speech. It used to happen in machine learning, vision, and NLP, the textual processing of AI, but it was never like that in speech. In speech, we never release code or source code or databases for free. It was never like that. It was very commercial. And only recently, I think 5 years, maybe.
Yeah.
Maybe, I don't think even 10, 5 years, we are releasing code. The papers are written much more in a way that you can reproduce the results. And that is super important for the humanity to advance,
What do you think what are some of the bigger problems that AI speech can solve?
So if you look at that in a broad way, the language changes every 100 years approximately. This is what we say linguistically. So you have new words. It will be hard for you to speak with your grandfather. He or she will not understand everything. You will speak too fast, maybe. You change the way you pronounce things a long time. And this is a big challenge, but we are not there yet, because we didn't have this challenge. The AI is trained on something which is currently American English from I think the 80s is the oldest data set we have. 80s, maybe 90s, that's it. And this is a big challenge. The other challenge is that we don't have enough data from other languages. And even if we have data from other languages, this is a big challenge, because language is what describes the culture of a country, of a group of people. And I think it's more than that. Just the language is the way it is spoken. It's the way you speak. It's for some person, one language can sound violent or too soft, or and this is something cultural that you have to keep in mind. You have not to offend anybody. You have to tune yourself when you do speech synthesis, when you do automatic speech recognition. It's not always trivial. And we are not even thinking about that. We are just thinking about getting more data, but we eventually will get into those scenarios which are way much more difficult, because we never have a united view of the language in technological way. And that would be a great challenge. We have the small challenges, the noise, the accents, but I think the bigger challenges would be different cultures, different way of speaking, different rhythms. Japanese has the mora, Italian has a different way of rhythm. The American English has a different way.
That makes sense. Let's transition to the future a little bit. What are some of your perspectives on where things will go in the future? You mentioned 10 years ago, you didn't think we were going to achieve human level performance.
Right.
Now we have these fundamental building blocks that are accelerating everything. Where do you think things will go? What are some perspectives on the future?
In speech, we are not there yet. I think we can have much more spoken data, especially under different conditions which are not read speech or a standard. I think even conversational speech, we don't have enough data, and that would be interesting. I think it would give a huge boost in transcribing conversational speech, which we are not superhuman now. But you can consider other things. For example, detecting various human conditions So you can use speech, and we have research about that we can detect social anxiety. We can detect various types of schizophrenia. If schizophrenia is a disease that causes motor elementary misfunctioning and or overfunctioning, and we can find it using speech. We can find I guess we will be able to find the onset of Parkinson's disease and all the motorical diseases before you don't need to it's something that you can do over the phone. We will be able to detect childhood asthma, which is something that you can do maybe with any Amazon Alexa device, which you will put in the kid's room. We'll be able to detect if the kid is under asthma attack or something like that. It's something super feasible. We need data. We need algorithm. I think the algorithms are there, but we need the data.
Nice. So as we think about the future, more data will help us be a lot more accurate in these different fields. Even though we've gotten superhuman level now, it's like not everywhere. And then with that data, in even today, we can start working on recognizing certain diseases or conditions with human speech recognition. And you think that's a big part of the future?
I think, and I'm speaking. I think about only those diseases or conditions that have motor evidence. So I think, for example, depression would be harder because depression is many things. Sometimes people with severe depression, with major depression, speak slowly, but if you have a small minor depression or major depression without any motor evidence, you wouldn't be able to detect that by speech or other conditions which doesn't have any effect on the motor control. I think in speech, the way you speak sometimes is unconscious. One of the parameters in speech is the stop consonants duration, the duration of PTK, BGT, PTK. Those small stop consonants, they are very short. They can be 30, 40, 50 milliseconds long. You can control their duration, but under various conditions, it's going to be changed, and you can detect that automatically. We can detect them very accurately, this duration. And let me give you an example of such a detection. So, for example, your parents, if your parents are, let's say, Brazilian Portuguese, but you live in America, you were born in America, for all your life you speak fluent American English. What we found out in research that those stop consonants will shifted, because in American English those stop consonants have a typical duration. In Brazilian Portuguese, the duration is way much longer. And as a person whose parents are Brazilian Portuguese, you will have some shift. They will not be as long as the original correct Brazilian Portuguese, but there will be shift that you can detect. And that is something people are not aware of. But I guess it's only the beginning of those type of analysis.
Nice. So we have like this great foundation. We can keep narrowing in essentially and getting more and more accurate around all these particulars. What about concerns? What concerns do you have as we think about the future?
So one of the major concerns is deepfake or deep voice fake. When a person tries to train a system so as to mimic a voice, and then we are going to the regime when the fact is not a fact, and somebody can say something about somebody else without even be aware of that. And I think today where this voice, the synthetic created voice, is not as good as the original person, but I think we are stepping there. And if somebody has enough data of the target person, I think there's no way why should he not create an amazing voice. amazing synthetic voice. And this is a big concern. We will not be able, at some point, we will not be able to detect that automatically. And we are know today that this is theoretically, we will not be able to detect that. And that is a major concern. There is another concern, which is more broad and in the level of regularity of AI. In these days, I'm writing a book which try to redefine what should be the regulation for AI. And what I'm claiming is that we should have a morality infrastructure in those AI systems. The idea is that AI can be connected to the real world. AI can, in the future, or maybe in the near future even, can think of its own algorithm and in its own way to improve itself. And improving itself means it can retrain itself so as to be better than human and maybe take over humanity. So if you're thinking about of Disney's movie Fantasia, and there is this Mickey Mouse, you remember if they filling the buckets endlessly, and actually we say in the machine learning world, the loss function was never satisfied. So it was and it couldn't stop that. So we won't be able to stop that. So this is a huge concern, and my claim is that we need a moral infrastructure rather than laws, because laws were defined. They were defined primarily by Isaac Asimov in his book I, Robot, when he defined a robot cannot hurt human and so on. But the rules will not be obeyed by smart AI. So we need infrastructure, and infrastructure for laws, for such laws is something that we can borrow for humans. So humans created a mechanism. According to Freud, we have a three part of the main soul. The part not soul of the mind. So
right.
The part are the id, our desires for food and sex, and the basic desires. There is another part which is called the ego, which is how we communicate, our ability to be with the outside world. And there are other parts. One of them is called superego. Superego was created by natural selection, by the evolution, and it was created so as that groups of people, groups of mammals can live together, and probably they were better than those individuals without superego. So you can see primates or monkeys that have an alpha monkey, and they somehow obey the law. Let's call them laws, but it's not laws. They obey this alpha monkey. The superego create fear. It create guilt, and it create a mechanism that we feel bad when we don't obey the law. We don't need to be in prison to obey the law. We just feel bad internally when we don't obey the law. And this is what I claim need to be part of any AI system. This should be the regulation, so as that the AI will create this digital ego, superego. This means that any AI system should include a mechanism that will self-hurt the AI. So it will either destroy the AI if it doesn't obey the law, or it will create some other hurt to the AI if it doesn't obey the law. This mechanism should be part of the AI, and something like that can also solve other problems. So, for example, whose fault is when you have a car which is autonomous car, and there is a crash? Whose fault is the crash? So you cannot. It can be the fault of the manufacturer, but we live in a world that the fault is always by the owner. So if we have this infrastructure and we somehow can upload the superego of the person who owns the car to the car, this means that the owner is fully responsible to the car. So if this guy has a big superego and is very responsible, the car will be very responsible. But if this guy is not responsible, that's fine. The car won't be responsible, but he will take all the responsibility if there is something happened, the human. And I think this can solve some of our problems in future AI.
Thank you. I think those are some deep thoughts. But I know this is a time of deep thinking as we see these advancements going so fast. It has us reflecting on technology, and I mentioned this before, but it has a life of its own. And so as we design the future with intent, we have to be thinking about how do we create the best outcome. As we think about AI, I like to think that it's still artificial. In a sense, it can't go beyond its programming. But what programming is built in? What controls are built in? We give it the ability to control what it can control. But are we also, do we have controls in that say tell a drone that it can't shoot anyone? Like what controls are we building in? And I think we always want human intervention. I do like Microsoft's position around Copilot, but Copilot implies that we're still the pilot, right? We're still in charge. And so how do we build in those mechanisms? And then also, as it gets more and more intelligent, build in these mechanisms that were redesigned and programmed in, these controls. That sounds really important. And I'm glad you're thinking about it. You're writing a book about it?
Yes, I am.
Awesome. That's great. Any other thoughts on the future as we think about the future of speech AI, that where it's going, what we need to be concerned in about, how we build in, intent? Want to capture any last thoughts there?
Again, we need to think about all the communities, all the different cultures around the world. We don't want to end up with one culture. Speech is a reflection of the culture.
Right.
And it's something we need to take into consideration, maybe not now, but it's something we need to build. This is something important. It's not important as the regulation and the security of AI. But again, it's important to keep the personal and the community and the cultural level of each of us.
Mm-hmm. I think that's really a big thing, that if AI is a reflection of us, of what it is trained on, but it's only trained on a certain subset of information that doesn't represent the world at large. And if speech is evolving every 100 years, like you mentioned, I could see how the training of the data is sort of an indication of the future, right? Because if we're going to be using these systems more and more, yes, what are we gaining? What are we losing? Maybe we're standardizing, but we're losing culture and language in the process, or community. So that's really interesting thought to contemplate as we think about how these AI models are starting to shape the future and are changing us already so quickly. What are some of the advancements in AI that you're most excited about? There's obviously everything going on in AI speech, and I felt your enthusiasm, but what are some of the advancements you're looking forward to?
Again, I think any medical healing, medical identification of medical problems, understanding the brain. We have in my lab, we have now started experiments when we compare the internals of this speech recognizer, the automatic speech recognizer, with the internals of the brain. So we do fMRI when we try to find out the location of the processing of the speech from the ear to the syntactic to the semantics. And then we compare that to the performance and the location of Whisper, for example, or any other speech recognition model. And we try to correlate them. We try to find out the attention that happens in the human brain and the attention happens in those trained machine. And that is fascinating because I think maybe we can understand more about the brain, actually. There is a known work from Charlotte Cachateau in France from Meta. She compared that to a large language model, the brain activity, and she saw that there is correlation between different level of the LLM, the large language model, and the brain, and that is fascinating. And it's still only the beginning of maybe understanding the brain by the machine, or vice versa. We don't know. We don't know yet.
That's crazy. That's deep. What's been one of the, what's been most rewarding? You've been so deep in this space. What's been kind of the most rewarding experience being in this industry?
that it works. It really works. You connect a computer program and it's influence the actual physical space. This is what fascinating me from the beginning. The physical space was speech, microphone, loudspeaker, but it's unbelievable that it happens. The connection.
And that can happen in our pockets now too, right? It's like we carry these computers around with us, and all that can happen in such a small form for an everyday person. That's amazing. As just to wrap up on this topic of AI speech, as you think about if someone's listening, they want to go deeper, what are some, who are some, you're a leader in the space. What other institutions or industry publications and or books, or like, what are some other resources where people can go deeper in this space that you would recommend that you value?
So first, we don't have books. When I teach, we don't have books. We don't have books for even for standard AI. The books are always delayed, and it happens so fast. So we don't have really good books on that.
Okay.
And if there are, I think they are not state of the art. The institute is like Johns Hopkins University, CMU, Carnegie Mellon University. There are great places. Southern California University is amazing. Meta, Google, OpenAI are great places. Google, Amazon. Those are the
state of the art. These are the places to look.
Edinburgh University. Yeah, there are a few.
The big tech companies and kind of their focus around speech AI, and then what some of these kind of top tier universities are doing as they have focused on this research as well. Thank you. Well, Yossi, any other parting words for the listeners today that you want to share?
Yeah, don't believe anything. Don't believe in non-facts. Compare everything, because now we're in a world that facts and non-facts are the same. So we need to be careful and read something which has some verification on that. Be more scientific. We also need, we need also the humanities. We need philosophers. We need literature writers. What's going to happen? What is the philosophy of AI? We need that.
Yeah.
We definitely need that. The philosopher to say something about the morality here.
Thank you. Well, good stuff. Good to have you. We appreciate your research, all your leadership in this space of speech recognition, speech synthesis, speech AI, and also your perspectives on the future. Be good to keep following you, especially as you're writing this book, as you're thinking about the bigger concerns of AI and how we shape the future and design the future with more intent. Really appreciate you being on the show.
Thanks so much for having me.
The Future of Podcasts is brought to you by Fresh Consulting. To find out more about how we pair design and technology together to shape the future, visit us at freshconsulting.com. Make sure to search for The Future of in Apple Podcasts, Spotify, Google Podcasts, or anywhere else podcasts are found. Make sure to click subscribe so you don't miss any of our future episodes. And on behalf of our team here at Fresh, thank you for listening.